You stand at 7,900 feet in the Peruvian Andes. Mist rolls through granite walls that shouldn't exist. 8,000 tourists walk past every day and miss the real question. How did anyone build this without wheels, without iron, without knowing what an earthquake would do 500 years later? The stones fit tighter than modern concrete. The drainage still works after 5 centuries of rain. 60% of the construction sits underground where nobody looks. Scientists with lasers and ground-penetrating radar keep finding things that make the mysteries deeper. They abandoned it 90 years later. What they left behind breaks the rules. A population that vanished, leaving only 173 skeletons when the city housed up to 1,000 people. Hidden chambers detected but never opened. Construction techniques that experimental archaeologists cannot replicate with period tools. Also comment from which city you're hearing this from. This script is researched and factual using sources from Kenneth Wright's 20-year hydraulic study, published by the Wright Paleohydrological Institute, the Peru Geological Mining and Metallurgical Institute's Cusco Pata Research Project, published in 2018 through Andina State News Agency, and Lucy Salazar's 2023 Genetic Diversity Study from Yale, published in Science Advances. These aren't tourist websites. These are primary research sources, with measurements, excavation permits, and peer review. Now back to the information. Lima and Cusco have been leveled multiple times through history. Machu Picchu stands untouched after 500 years. Held by gravity and friction and three-dimensional puzzle geometry that engineers with computer modeling still struggle to understand, changed their entire approach. Before the quake, they used smaller stones and cellular architecture. After the quake, they switched to giant blocks at the base with narrower, inward-inclined upper walls, trapezoidal openings, walls tilted 3 to 5 degrees inward. Every design choice aimed at one thing, surviving the next shake. But creating joints that allow controlled movement in 3 dimensions without modern tools or mathematical modeling, that's the mystery. Modern laser scans show walls shift millimeters during tremors before settling back. Kenneth Wright estimated 60% of construction effort went underground. Foundations, drainage, crushed rock layers 9 feet deep below the main plaza, 3 feet of curated topsoil, 6 feet of specially graded fill material. This invisible work is why Machu Picchu stands, while Spanish colonial buildings in the same region crumbled. The quarry sits nearby, but nearby means across broken mountain terrain at 7,900 feet elevation. No wheels, no horses, no oxen, no pulleys, bronze tools, wooden levers, human muscle. That's the inventory. Precisely graded ramps that are themselves major construction projects. Rest platforms positioned exactly right. The Inca roads show this infrastructure existed. Roads with calculated inclines and strategic stopping points, designed for moving materials, not people. You have to lift them, angle them, set them perfectly on the first try, because you can't adjust a 50-ton stone after it touches down. Tool marks on quarried surfaces suggest systematic techniques for splitting stones along natural fracture lines. Fire heating and water cooling create cracks. Bronze tools and wooden wedges exploit geological weaknesses. That explains extraction. Modern attempts to replicate the process require extraordinary time investments and skill levels. The Incas did this across miles of mountain terrain on a timeline that matches construction between 1450 and 1540. 90 years to build an entire city. Specialists theorize the Incas understood techniques for controlling stone fractures through precise force application and possibly sound resonance. These techniques might have achieved results similar to modern stone-cutting methods, but nobody knows how, and the Spanish conquest destroyed the knowledge transmission systems before anyone wrote it down. Most tourists photograph the terraces and the Temple of the Sun. Almost nobody notices the greatest engineering achievement runs underground and through every stone channel across the site. Kenneth Wright is a civil engineer who spent 20 years studying Machu Picchu's water system. When his team excavated the main plaza in the 1990s, they found what changed everything. 3 feet of rich topsoil carefully curated for drainage, 6 feet of specially graded fill material, white granite chips deliberately repurposed from construction waste, creating a porous layer that has functioned perfectly for 500 years. The entire city drains through 130 plus drainage holes built into original wall construction. No standing water, no erosion. No mudslides, despite 2,000 millimeters of annual rainfall. Main canal. From there, the Incas constructed a canal 749 meters long. The gradient sits at 3%. Exactly 3%. That gradient provides optimal water flow without erosion, a principle still used in contemporary hydraulic engineering. The typical yield from the primary spring ranges 25 to 150 liters per minute. The ancient engineers planned for variation. The canal enters the agricultural sector first, then crosses into the urban zone, feeding 16 fountains known as the Stairway of Fountains. Fountain 1 sits at the Emperor's residence, priority access, 26-meter total vertical drop from first to last fountain, gravity-fed system requiring 0 mechanical pumps. Stone spouts shaped specifically for arabalo jugs, which are traditional Inca water vessels, circular drainage connecting each fountain to the next in sequence. Surface drainage directs agricultural and urban stormwater away from the domestic water canal. The Incas maintained drinking water purity by keeping runoff separate from supply. This required understanding watershed dynamics, contamination pathways, and hydraulic separation at a sophistication level that Wright's team with modern analysis concluded rivals modern systems. The channels were either completely impermeable or semi-permeable depending on function. Under the central plaza grass, the ground is gravel, allowing water to flow through. Without efficient drainage, the accumulated water could have caused the city to slide down the mountain. Wright explained the way it works isn't visible to the observer. It is all hidden out of sight. 60% underground. The visible fountains are beautiful. The invisible infrastructure is why Machu Picchu didn't become a mudslide 500 years ago. It looks like a small pyramid with a column feature believed to have been used to tie the sun. Perfect balance. Archaeological astronomer Gary Urton's research reveals the Intihuatana's angles and surfaces align with multiple astronomical phenomena simultaneously. Eastern alignment faces Mount Veronica where the sun rises during equinoxes. Northern alignment points toward Huayna Picchu. Western alignment matches the Pumasilo mountain range where the sun sets during summer solstice. This is an approximate. Three-dimensional laser scanning identified subtle angles tracking the Pleiades constellation. Astronomical alignments at Machu Picchu prove accurate to within 1 to 3 degrees of arc, precision that rivals many modern observatories. Periods. The Temple of Three Windows, the river Intihuatana at the gorge base, and Lactapata Sun Temple, 5 kilometers across the valley, all lie on the axis of June solstice, sunrise, and December solstice sunset. On the horizon beyond is where the sun rises on June solstice and points near the heliacal rise of the Pleiades. This topographical astronomical relationship spans kilometers with alignments calculated without telescopes, without theodolites, without any optical instruments we know the Incas possessed. How did they embed multiple simultaneous alignments into single stones? The Intihuatana tracks solar positions accurate to within 15 minutes throughout the year. Modern astronomers with computers and GPS struggle to explain the methodology. The precision is documented. The technique remains unknown. The water engineering that works 500 years later? Drop your thoughts below. And if you haven't subscribed yet, do it now because we're only halfway through these 12 mysteries. Basic demography says hundreds or thousands of people lived, worked, and died at the site over 9 decades. Hiram Bingham's 1912 expedition excavated 174 individuals. Subsequent excavations pushed the count to about 200 skeletons total. The missing population puzzle deepens with demographic analysis of recovered skeletons. Approximately 75% of remains belong to women, many showing signs of high-status lifestyle, including good nutrition and minimal physical labor. Lucy Salazar's genetic study, published in Science Advances in 2023, analyzed DNA from 68 individuals, 34 from Machu Picchu and 34 from Cusco. The results revealed substantial genetic diversity. People came from highlands, coastal regions, Amazon lowlands as far as Brazil and Paraguay. The mother came from Amazonian lowlands. The daughter grew up in highland or coastal Andes. Everyone buried together in major cemeteries regardless of ancestry, suggesting equal status. Theories include off-site burial practices, body removal during abandonment or undiscovered burial areas. None fully explain the dramatic discrepancy. Conservation restrictions limit excavation. Ground-penetrating radar detects underground anomalies, suggesting possible hidden chambers, especially beneath the Temple of the Sun. But no one can dig there to confirm. Were these the virgins of the sun as Bingham initially believed? DNA analysis proved early osteological conclusions were wrong. Determining gender without pelvic bones is difficult. But even with corrected ratios, the population doesn't account. 1,000 people over 90 years should leave far more than 200 skeletons. The missing thousands haunt the site. Kenneth Wright stated the most important work at Machu Picchu isn't visible. 60% of construction effort was underground. Foundations extending deep into bedrock, crushed rock drainage layers, carefully engineered fill material. The plaza excavation revealed 9 feet of subsurface preparation. Most of the terraces, 4.9 hectares total, include sophisticated underground drainage systems with adequately sloped surfaces. Good. Subsurface drainage and remarkable surface drain networks. They're engineered to flex during earthquakes. The stones at the base are massive. Stones near the top are smaller and lighter. This weight distribution lowers the center of gravity, creates compression forces that hold structures together during lateral movement. Without them, the steep 70-degree slopes would erode catastrophically during the rainy season. The Incas essentially regraded an entire mountainside, cut into the ridge, moved thousands of tons of earth and stone, created a relatively flat space for the city. All the excess material went into terraces that simultaneously produced food and prevented landslides. That's dual-function engineering at scale without modern earth-moving equipment. Agricultural terraces photographed by Hiram Bingham in 1912 showed intact walls. The longevity came from drainage design built to withstand gravity and time. Recent LiDAR surveys, using drone-mounted systems in 2024 and 2025, revealed structures hidden beneath centuries of jungle growth. Over 12 previously unknown structures in areas never excavated. Residential quarters, ceremonial complexes, sophisticated water channels extending far beyond the visible tourist areas. The LiDAR penetrates dense vegetation, showing Machu Picchu was not an isolated mountaintop retreat, but the hub of a geographically vast complex. The 2024 discoveries used improved sensor technology, optimized flight parameters with lower altitude, slower speeds, increased overlap, and advanced processing algorithms with better vegetation filtering. Each discovery revealed more underground infrastructure, stone channels buried under soil, foundation systems supporting structures long collapsed, ceremonial platforms that functioned before the main citadel was built. Excavation restrictions protect the site, but also prevent investigating the anomalies. Ground-penetrating radar suggests rooms and possible burial chambers remain sealed. The tension between preservation and investigation means mysteries stay mysteries. Inca architectural techniques included methods for concealing doorways and chambers using precisely fitted stone blocks, virtually invisible once sealed. The absence of obvious sealed entrances doesn't preclude their existence. Discovery of sealed chambers could resolve questions about high-status burials, storage of valuable objects, and administrative records explaining the site's purpose and history. Recent estimates suggest only 30% of the site has been thoroughly investigated. 70% sits waiting. 60% of the construction you can't see. 40% of what's visible hasn't been excavated. The math says most of Machu Picchu remains unknown. Actual knives. Actual zero tolerance. Polygonal stones feature 12 or more precisely angled sides interlocking with surrounding blocks and complex three-dimensional puzzles. The famous 12-angled stone sits in nearby Cusco, but Machu Picchu contains hundreds of similarly complex polygonal blocks, proving this wasn't isolated achievement, but systematic construction technique. Hammerstones made from harder granite, wooden wedges, sand for abrasion, no iron, no steel, no diamond cutting equipment. Modern attempts to replicate Inca stonework using period-appropriate tools achieved impressive results, but required extraordinary time investments and skill levels, suggesting original builders possessed techniques or knowledge not fully understood by contemporary craftspeople. First, identify stones in the quarry that match the space being filled. Split along natural fracture lines using firewater bronze and wooden wedges. Transport to site using rollers, ropes, and thousands of workers. Then begins the real mystery. Rough shape the stone using hammerstones and bronze chisels. Test fit it against neighboring stones. Mark high spots. Remove material. Test again. Repeat until perfect fit achieved. But that process takes months per stone for complex polygonal blocks. Machu Picchu has thousands of these stones. The time budget doesn't work unless they had methods that dramatically accelerated the fitting process, using percussion patterns that sound different when you hit the right spot. These claims are hard to verify scientifically, but the results they produce are impressive. Tourists can watch them work. They achieve tight fits faster than experimental archaeologists using trial and error methods. The knowledge might exist in living tradition. It just isn't written down in forms that academic research can easily verify. Tool marks on quarried surfaces show systematic approaches to splitting stones along natural fracture lines. Fire heating stone, then rapidly cooling with water creates thermal stress fractures. Bronze tools and wooden wedges exploit these geological weaknesses. That explains rough shaping. What doesn't explain is the final fitting precision. Three-dimensional accuracy on irregular polygonal blocks with 12 contact surfaces. Each surface perfectly matching its neighbor. No computer-aided design, no laser measuring tools. No way to test fit 50-ton blocks multiple times. Experimental archaeology hasn't replicated the efficiency. The standardization of stone sizes and shapes across different areas suggests systematic quarrying and preparation with quality control measures. But the quality control methodology isn't documented. Broader areas. During seismic events, complex joints allow controlled movement while maintaining structural integrity. The geometry optimizes structural performance. Mathematical analysis of trapezoidal proportions reveals consistent ratios, balancing efficiency with aesthetic harmony. The Incas developed standardized geometric relationships. Where those relationships came from, nobody knows. The stones prove the knowledge existed. The transmission of that knowledge died with the Spanish conquest. The site sat uninhabited for nearly 400 years, growing over with jungle until Hiram Bingham arrived in 1911. From 1536 to 1572, Manco Inca and his successors recruited every able-bodied warrior to resist Spanish domination. They sought refuge in the more remote Vilcabamba region, in river basins of Vilcabamba Vitcos and Pampacona Concebidayoc, instead of using Machu Picchu as home base. Perhaps the location wasn't defensible enough. Perhaps Vilcabamba's jungle offered better concealment from Spanish forces. Disease presents another explanation. Foreign-born plagues decimated indigenous populations during contact. Smallpox swept through the Inca Empire before Spanish soldiers arrived in many regions. The epidemic killed Inca Emperor Huayna Capac in 1527. If plague hit Machu Picchu, why were so few human remains found? If people fled disease, they left behind the dying and dead. Where are they? The clean abandonment with personal items left in place doesn't match plague evacuation patterns documented at other sites. The Spanish conquest of Cusco in 1533 disrupted Inca administrative systems. Resources that maintained royal estates were redirected to resistance efforts. Workers who served at Machu Picchu returned to their homelands or were reassigned elsewhere. The site lost its function and was simply left to the jungle. This explains the lack of violence and the relatively orderly abandonment, but doesn't explain why nobody came back later, when Spanish pressure decreased in some regions. Working-class citizens who made up most of Inca society didn't know Machu Picchu's existence or whereabouts. Knowledge of routes was restricted to elite. When the elite abandoned or died, the location was forgotten. But local families were living among the stones when Bingham arrived. Indigenous communities knew the site existed. The Western world lost knowledge, not the local population. Recent research questions whether Machu Picchu was ever truly forgotten. 60 years of research hasn't answered. Archaeologists initially believed the cave served as a mausoleum for royalty. Stone staircase leading nowhere. Niches carved into walls with no obvious purpose. Fine stonework indicating high-status construction. But no royal burials were found. No grave goods. No explanation for the architecture's purpose. The cave remained sealed for centuries before excavation. What was found contradicted expectations. The chamber doesn't match typical Inca burial architecture. The staircase orientation makes no functional sense. The carved features suggest ceremonial use, but what ceremonies aren't clear. Inca construction techniques included methods for sealing important spaces virtually invisible once completed. Precisely fitted stone blocks create walls indistinguishable from solid construction. You wouldn't know a doorway or passage existed without detailed mapping. Preservation of administrative records explaining the site's purpose and history. But exploration faces significant challenges. Conservation concerns prevent excavation. Risk of damaging existing structures stops investigation. Technical difficulties accessing underground spaces and mountain environments limit options. The Temple of the Sun keeps its secrets. The cave underneath raises questions that decades of study haven't answered. Number 10, genetic diversity that defies expectations. Lucy Salazar's 2023 study, published in Science Advances, revealed Machu Picchu was substantially more genetically diverse than contemporary rural villages in the Andes. The finding contradicts expectations for an isolated royal retreat. DNA analysis of 34 individuals from Machu Picchu burial sites showed origins spanning the empire, coastal Peru, northern highlands, Bolivian Altiplano near Lake Titicaca, Amazonian lowlands, even connections to regions as distant as Brazil and Paraguay. Only one mother-daughter pair identified among all individuals tested. Everyone else showed no close family connections. This suggests servants arrived at Machu Picchu as individuals, not as communities or extended families. Mother came from Amazonian lowlands. Daughter grew up in highland or coastal Andes based on isotopic analysis. Why this gender-based geographical difference? The data suggests it, but doesn't explain it. Were women specifically recruited from distant regions? Did labor organization involve gendered geographical patterns? Specialized craftspeople recruited empire-wide to serve royal household. Yanacona and Ackley servants documented in Inca administrative systems. But the genetic diversity exceeds what anyone predicted. Machu Picchu functioned as a melting pot, drawing skilled workers from across 2 million square kilometers of Inca territory. The genetic signature proves long-distance mobility and diverse recruitment far beyond local populations. This creates tension with the missing population mystery. If people came from across the empire to work at Machu Picchu, where did they go when the city was abandoned? Did they return to homelands? Were they relocated to other royal sites? The genetic evidence shows they arrived from far away. Nothing shows where they went, 1450 to 1540. Emperor Pachacuti initiated construction around 1450 after defeating enemies and consolidating power. Archaeological dating using ceramics, radiocarbon analysis, and historical records confirms the timeline. 90 years to build everything: terraces, buildings, water system, roads, ceremonial centers, over 150 stone structures in the main citadel, agricultural terraces covering 4.9 hectares, 749-meter canal system with sophisticated engineering, underground infrastructure representing 60% of construction effort, astronomers for alignment calculations, administrators for coordination, all working at 7,900 feet elevation in a location requiring supplies transported up mountain trails. The organizational complexity matches or exceeds any contemporary civilization. But the Incas had no written language, no paper, no detailed construction plans archaeologists ever found. They planned and executed everything through oral transmission and hands-on demonstration. Quarrying, transporting, and fitting stones for 150 structures with multiple rooms and precise alignments demanded continuous effort from specialized craftspeople. Engineering and installing a 749-meter canal system with exact 3% gradient required surveying tools and mathematical calculations that had to be accurate, or the system would fail. Creating foundations 9 feet deep under the main plaza meant excavating hard mountain soil and bedrock, then carefully layering drainage materials. Installing 130-plus drainage holes into walls during construction required coordination between stonemasons and drainage engineers. Aligning structures with astronomical phenomena required years of observations to establish sight lines, then embedding those alignments into permanent architecture. Training enough skilled workers to maintain quality standards across all these simultaneous projects required robust knowledge transmission systems. Supply lines for food tools and materials have to function reliably up difficult mountain approaches. Any delay in one system cascades through the project. Yet they finished in 90 years with results that surpass many modern projects. Moving 50-ton blocks using wooden rollers and human labor, possible but slow. Cutting stones to millimeter precision using bronze tools, achievable but time-consuming. Excavating 9 feet deep across the entire plaza, doable but labor-intensive. Added up, multiplied by the number of structures and stones and terraces. The 90 years becomes tight, very tight. The construction happened. The evidence sits on the mountain. The timeline math creates tension with the methods archaeology can verify. What's documented is that they finished in 90 years starting from raw mountainside. Modern construction with bulldozers and cranes would find that timeline challenging. After 500 years, including centuries of abandonment with no maintenance, the drainage system still functions perfectly. Kenneth Wright's team during 1990s excavations discovered ceremonial fountains on the eastern flank. When debris was removed, the fountains sprang to life and flowed again after 450 years. Subsurface channels directing water away from foundations, graded surfaces ensuring runoff moves correctly, white granite chip layers providing permeability. The integration means water from rain and spring flow moves through the system exactly as designed. No modern repair, no maintenance for centuries, still working. Civil engineers study the design for modern applications. The principles work with natural water flow rather than fighting it, put most effort into invisible infrastructure, use local materials creatively, design for extreme conditions, integrate function across systems, still inform contemporary sustainable construction. Stone spouts still shaped correctly for filling vessels. Circular drains still connecting fountains in sequence. Overflow channels still diverting excess during high flow periods. Every component functioning as built. The longevity proves the Incas understood hydraulic engineering at sophistication rivaling modern systems, per Wright's published analysis. They achieved this without detailed mathematical calculations, archaeologists can find. No written formulas for gradient optimization, no tables of flow rates and channel dimensions, no preserved design documents explaining drainage hole placement. The knowledge existed, the knowledge worked, the knowledge disappeared. Modern engineers analyzing the 3% gradient calculate that it optimizes flow velocity while minimizing erosion, a sweet spot in hydraulic design. The Incas hit that sweet spot across 749 meters of hand-cut stone channel at 7,900 feet elevation on a mountain slope, without computers, without written records, without trial and error unless error meant catastrophic mudslides. 12 documented engineering impossibilities that scientists with modern tools cannot fully explain. Not aliens, not lost civilizations from before the Incas, just knowledge and techniques that work so well the results outlasted the civilization by 500 years. The dancing stones that survive earthquakes, the 50-ton blocks moved without wheels, the hydraulic engineering that still functions, the astronomical precision without instruments, the missing population that doesn't add up, the underground infrastructure 60% hidden, the cutting precision without iron tools, the abandonment mystery with no explanation, the temple's sealed secrets, the genetic diversity spanning empires, the timeline that barely fits, the drainage that never fails. Recent LiDAR in 2024, published in June 2025, found a buried stone carving beneath vegetation on the eastern terrace. When excavated, it showed a three-dimensional topographical model of the surrounding mountain peaks carved into granite. The Incas made a physical three-dimensional map of their astronomical sightlines, carved in stone, oriented to match reality. Accurate enough that modern GPS confirms the mountain positions. This carving sat buried for 500 years. Found by accident with laser mapping that sees through jungle. Sometimes the most sophisticated engineering is invisible. Sometimes the greatest achievements leave the fewest written records. Sometimes entire knowledge systems vanish when conquerors destroy the people who carried them. The stones remain. The technique is gone. We measure what the Incas built and cannot fully explain how. Language who solve problems modern engineers struggle to replicate. The answer isn't aliens or lost technology. The answer is us, humans, capable of engineering marvels when we need them, then forgetting how when knowledge transmission breaks. Machu Picchu proves we were always this smart. The mystery is how much we've forgotten. Every peak positioned correctly, carved before 1540, found in 2024, 500 years in the ground waiting. What else waits under stones? We can't move in jungle, we can't cut in ground, we can't disturb, because doing so would destroy what we're trying to understand. That's the final mystery. Not what the Incas knew, but what we'll never recover, because preservation and discovery are enemies. You save the site or you learn its secrets. Choose one.